Right, hey guys. So this is going to be our online class for today. This class is going to be on composite functions, um, inverse functions, and compound functions. It's not that difficult. It's a little bit of algebra. Now, please make note that if you did not watch the video on functions and relations, then you should definitely watch that video and understand that video first before you tackle this one, right? Now, of course, if you all have any questions or you don't understand anything, please feel free to call me or WhatsApp me or even leave a message in the Edmodo or a comment, and I'll definitely get back to you as soon as possible, right? Right, so let's get started with this composite functions. Now, let's consider this equation here. F of x is equal to x squared plus 2x plus 3. Now, remember f of x is basically y, right? So I could have here y equals f of x. And please excuse my handwriting. I'm still getting used to writing with this weird thing, right? Now let's try when x equals 1. Now we know that when x equals 1, what I have to do is I have to take this number 1 and I have to put it everywhere I see x. So I have to put it here, I have to put it here, and I have to put it here. Everywhere I see x, I have to put that 1. So when I have the f of x is this equation, and I want to know when x is 1, what I'm actually doing is I'm actually asking for the f of 1. Yeah? So you could see that I just put that 1 where the x is supposed to be, and I will say that is equal to, and I will write out my equation here, but I will just have 1 in replace of x. So everywhere I see x, I'm going to put 1. So you can see I have x squared plus 2x plus 3. And then we could just work it out, right? 1 squared is 1, plus 2 times 1 is 2, plus 3, and we get the answer to be 6, right? So therefore, I could write this as a coordinate, right? As a coordinate, I have the x value is 1, and the y value is the f of 1, or the function when x is 1. And therefore, the x value is 1, and the y value here is 6, right? Yeah. So so we could see what's going on here. When I have this f of x, I could just literally write a number inside of this bracket, and that number will be the number that we substitute as x. So let's try another example. What about when x equals -1, right? So now I'll have the f of -1, yeah? And the f of -1 is essentially, I just taken this -1 and I'm putting it anywhere that I see x, right, in the equation. So it'll be x squared plus 2x plus 3. And what I'll have here is -1 squared is 1, and then 2 times -1 will be -2 plus 3. 3 minus 2 is plus 1, so therefore the answer here is 2, right? So in this case here, I have the coordinates, x is -1, and then the y coordinate will be the f of -1, or the value of the function when x is -1. So I have -1, and then the y value ends up being 2, right? So this is when we use the f of x notation to substitute a value of x. Right, so really and truly, I could substitute x is anything, right? So if x is 3, then I will put the f of 3. And that will be, anywhere I see x, I'm going to put 3. So it'll be 3 squared, or x squared, plus 2x plus 3. And that is 3 3s are 9, plus 2 3s are 6, plus 3. And therefore I will get 18. Hence, when x is 3, the f of 3 will be 18, right? So literally, whatever I put inside this bracket here, I will substitute in place of x. Yeah? So what if I have the f of this piggy over here? Well, that will just be equal to, and I'll just take that piggy and I'll put it anywhere that I have x, right? I'll just take this piggy, and that will be the piggy squared plus 2 times the piggy plus 3. Yeah? So whatever I put in this bracket, the f of the piggy means that I'll take this piggy and I will put this piggy wherever x is supposed to be. Yeah? And please remember that, because that's going to be important coming up next. Now for homework, I would like you to try these questions here. So we have question 1, and I want you to work out the f of -3, find the f of 5, you could find the f of 1/2, and how about the f of -7? Yeah. So we have these 4 questions here, and let's just see how you do with them. So you could practice them and send them in the comments and let me see how you do. Right, so let's check out this this other example here. You can see that I have one function, f of x is equal to 2x plus 3. And I have another function here, the g of x, which is x minus 2. Now, I could have f of x, I could have g of x, I could have the p of x, or the q of x, or the r of x, you know? All I'm saying here with this fg business is that they are both different functions. They're not the same function, yeah? Because they're different functions, we'll name them differently, right? Now, please remember what we were just talking about, that anything that I put in this bracket here, I will replace x with it, yeah? So if I had put 1 inside of this bracket here, then I would put 1 where x is, yeah? So what if I wanted the f of the g of x? Yeah, kind of blow mine, right? So you would see that I have the g of x inside of this brackets here. What is the g of x? The g of x is this equation. So I want this equation inside of this bracket here. So that means that I will now have the f of the g of x is x minus 2, right? And so now I am going to take this x minus 2 and put it anywhere in the f equation that I have x. Yeah? So what we're actually doing is we put in a function inside of another function. Yeah? So I am going to substitute the function g of x inside of f of x. Yeah? So now that I have g of x here, I will put g of x anywhere I see this x. So now the f of x is 2x plus 3, right? So therefore, the f of x minus 2 is taking this x minus 2 and I'm putting it anywhere I have x. So that will be 2 times x plus 3. And that will be 2x. And then 2 times negative 2 is minus 4 plus 3. And that will be 2x minus 1. So therefore, the f of the g of x is 2x minus 1. So what I did there, just as a recap, right? Remember, f of x is 2x plus 3. And I could really just substitute anything I want. I could have the f of 1, and I could actually take this 1 and put it anywhere I have x here. Yeah? And that will give me the f of 1, right? But what if instead of putting a value inside here, what if I was to put another function? I want to put the g of x. So this whole function I'm going to put inside of the f of x here. Yeah? So this entire function I'm going to put in there. So I will get the f of x, which is 2x plus 3, but every time I have x, I'm going to put g of x. Yeah? Plus 3. So let's try a different example. Right, so let's check this example here. I have the f of x is x minus 1, and I have the g of x to be 6x plus 5, right? Now I want the f of the g of x. And you'll notice here, and it's just like what the notation has, I want the g of x to be inside the f of x, yeah? So I'm going to take the f of x, which is x minus 1, and anywhere I have this x, I'm going to put the g of x. So g of x minus 1, right? That's wherever I have x, yeah? And so the g of x is actually 6x plus 5 minus 1. Therefore, the f of the g of x will be equal to 6x plus 4. So I could also do it the other way around. I could actually ask for the g of the f of x. So what I'm doing in this case is I'm taking the f of x, right? And I'm putting it inside the g of x, yeah? So let's recall the g of x is 6x plus 5. So I want to substitute f of x inside of this brackets here. So that's the g of, open brackets, the f of x. That means that anywhere I have x, I'm going to put f of x. So that is 6 times f of x plus 5, right? What is the f of x? Well, that is x minus 1. So that'll be 6 times x minus 1 plus 5. So that'll be 6x minus 6 plus 5. So I'll end up getting 6x minus 1. So the g of the f of x is 6x minus 1. So remember when we talk about the piggy and how you could substitute the piggy inside of the brackets, and then anywhere that you have x, you just put the piggy, right? Well, the point of the piggy was that it could be anything you could put inside that bracket, right? And it could even be another function, a different function. So I have a different function, f of x, inside of this g of x here. I want to substitute this f of x. Anywhere I have x, I'm going to put f of x. And then I will find this composite function, which is like a function inside of a function. Yeah? So let's take a look at a couple more examples. Right, so let's take a look at this next example here. I have the f of x is equal to x squared, and I have the g of x being equal to 3 plus x. So let's find the f of the g of x, right? Now, just like how if I wanted to find the f of 1, I would just take 1 and put it anywhere that x is, right? Also, if I wanted to find the f of 5, I would just take 5 and put it anywhere that x is, right? Similarly, if I wanted to find the f of g of x, I would just take the whole g of x and put it where x is in the f function, right? I would literally put the g of x function inside of the f function. So the f function is x squared. So if I was to put the g of x function, it would be the g of x all squared, right? And what is the g of x squared? That would be 3 plus x all squared. So that would be 3 plus x times 3 plus x. 3 times 3 is 9. X times 3 plus 3x. And then 3 times x is plus 3x. And then x times x is plus x squared. So we have 9 plus 6x plus x squared. And this is the f of g of x. Yeah. So what we have here is when we take the g of x and we put it inside of the f of x function, we will get this larger function over here. Let's try it the other way around. Let's try the g of the f of x. So you see in here that I have the g with the brackets, and I have this value inside of the brackets, and I am just going to take this value and substitute it anywhere I have x, right, in the g formula. So the g of x being 3 plus x means that the g of f of x would be 3 plus, I would put f of x anywhere I see x, right? So then that would be 3 plus x squared, and I don't think there's anything else we could do with that. So the g of the f of x is 3x squared, right? So I hope you do understand this concept, that basically I could substitute any value inside of an equation. In fact, I could even substitute another equation inside of an equation, yeah? And we call that composite functions. So let's just take a look at one other slightly more difficult example. Right, so if we check this out here, we have 3 examples. The f of x being 2x plus 5, the g of x being 3 plus x, and the function p of x being x minus 7. Now I have 3 functions here. I could actually sub one inside the other. So what if I wanted to ask you, and be ready to have your mind blown here, right? What if I wanted to ask you for the f of g of p of x? What is going on here? I have a function inside a function inside another function, right? Now, how do we operate this? Just work from whatever is inside the innermost function and work outwards, right? So first you would see here that I have the p of x and I want it inside of the g of x, yeah? So the p of x is inside the function g, yeah? Right, so I have the function g of x, which is 3 plus x, yeah? And I want to substitute the other function p inside of it, yeah? So, right, so I want to put the p of x wherever I see x in that g function, right? So I'll have 3 plus x, which is the p of x, yeah? So that would be 3 plus the p of x is what? X minus 7. So what is 3 minus 7? 3 minus 7 would be minus 4. So x minus 4. So therefore, the g of the p of x, this is when I have the p function inside the g function, is x minus 4. And now I'm going to put that entire thing, I'm going to put x minus 4 here inside of the f function. So the f of the g of the p of x, yes, I knew, right? That is, remember, this here is the g of the p of x, right? So that would be the f of x minus 4. So I'm substituting the x minus 4 in the f function. So the f function is 2x plus 5. And you see that I made the substitution there. I just put that wherever I had x. So that would be 2x, and 2 times 4 is minus 8 plus 5. So that would be 2x minus 3. So therefore the f of the g of the p of x, right, is 2x minus 3. Right? Now I know that it can be a little bit confusing. Just remember, if you are faced with something like this, right, if you do have to tackle something like this, just start with the inside first, work out what is this tiny one over here, and then plug it in the larger one, right? Nice. So what I'll do is I'll definitely leave some questions for you to do in the comments, right? I'll leave a worksheet there, so please get it done. And of course, if you have any questions or you don't understand or you're not sure how to do it, You could feel free to WhatsApp me or message me, and I'll help you. I'll help explain it to you, right? Right, so let's try to talk about compound functions. And with compound functions, we'll just use the very same functions that we had in the previous example. Compound functions are a little easier. This is where we just add functions, right? So I have here the f of x being 2x plus 5. I have the g of x here being 3 plus x. And I have the p of x being x plus 7. So compound functions is just what it sounds like. I'm actually just adding different functions together. So I could have something like this. What is the f of x plus the g of x? Yeah, so I'm just gonna add these two functions together. So the f of x is 2x plus 5. That's the f of x. And then I'm gonna add that to 3 plus x, and that is my g of x, right? So now I'll have 2x plus 5 plus 3 plus x. Oops. Yeah, plus x. And that will give me 2x plus x is 3x. And 3 plus 5 is plus 8. Yeah? So compound functions is just a matter of actually adding the functions together, right? So let's try a couple more examples here. Let's try the g of x minus the p of x, right? So the g of x is what? 3 plus x, and then I'm gonna minus the p of x, which is x minus 7, right? Now you can see I have this negative minus in front of these brackets here, so that means that this negative here is going to affect everything inside of these brackets. So if I expand out the brackets, I'll get 3 plus x, and this here will be minus x, and this here will be plus 7. Yeah, so x minus x, that goes to 0, and 3 plus 7 is 10. So the g of x minus the p of x is simply equal to 10. How about the f of x plus the p of x plus the g of x? I'm just gonna add all of them together, right? That'll give me what? The f of x is 2x plus 5 plus the p of x, which is x minus 7, plus the g of x, which is 3 plus x, right? So 2x plus 5 plus x minus 7 plus 3 plus x. Let's add all of our x terms. So the 2x here plus x, so that gives me 3x, plus another x, that gives me 4x. And then add the other numbers here now. I have 5 plus 3, which is 7. 5 plus 3, which is 8, sorry. And 8 minus 7 gives us plus 1. So the f of x plus the p of x plus the g of x will give us 4x plus 1. Yeah, so this is a little easier than the previous concepts that we were doing. You all should be able to handle this nicely, and I'll definitely be leaving some exercises for you all to do, so you'll check out those worksheets, and please follow the instructions carefully, because it's really important that I get the worksheets or the assignments for these online classes so that I could see how well you really understand it, right? Right, so now we're going to check out this concept called inverse functions, right? So a function, we describing a function as f of x. For the inverse of that function, we will call that f inverse x. So that is like a f to the power of -1 kind of thing, yeah? And that's how we refer to an inverse of a function. So what is the inverse of a function? Well, let's just check out the normal function, f of x here. And this f of x is 2x plus 5. Let's draw a mapping diagram. So I'll have my domain, which is my x values here, and that'll map on to my range, which is the f of x values or the y values, right? Now, according to this equation, when x is 1, if I put x to be 1, 1 times 2 is 2 plus 5, that is f of x will be 7. If x is 2, then 2 2s are 4, 4 plus 5 is 9. If x is 3, then 3 2s are 6, 6 plus 5 gives me 11. So we could see that according to this function here, when we draw the mapping diagram for the function, we have 1 is mapping on to 7, 2 is mapping on to 9, and 3 is mapping on to 11. Yeah? So this is what this function does. F of x maps 1 onto 7. F of x will map 2 onto 9. F of x will map 3 onto 11. And that's what this equation does, right? What I want to find now, I want to find the equation that will do the exact opposite. Yeah? So what I want to find is I want to find the equation that will do the exact opposite. That means that I want 7 to map back onto 1. I want 9 to map back onto 2. I want 3 to map back on to 11. Yeah? So I have to find the inverse. So the inverse of a function basically does the opposite, right? So let's see how we could find the inverse of a function, right? Remember, y is equal to f of x, yeah? So if f of x is equal to 2x plus 5, then I could say that y is equal to 2x plus 5, right? So in order to find the inverse of a function, and let's just say the question is find f inverse x, yeah? So I would have to take this function now and let's make x the subject of the formula, right? So 2x plus 5 is equal to y. So therefore 2x is equal to y minus 5. Therefore x is equal to y minus 5 divided by 2. All divided by 2, right? What I have to do now, because x is the subject of the formula, I just have to simply replace the x's and the y's. So what I would just do after I make the x the subject of the formula, I would just say, okay, well, y, I just replacing x with y is equal to, and I replace y with x minus 5 over 2. And this is the inverse of the function. Therefore, f inverse x is equal to x minus 5 over 2. Now let's check and see if this works, right? So let's draw a mapping diagram. I have my I have my domain x, and I have my range f of x, right? Or in this case, f inverse x, yeah? So in my domain, if I was to put x is equal to 7, right? 7 minus 5 is 2 divided by 2 gives me 1. So 7 maps back onto 1. Yeah? If I was to put my domain x is equal to 9, 9 minus 5 is 4. 4 divided by 2, so 9 would map back onto 2. Right? If it is that I wanted to have in my domain x is equal to 11, then I sub x is 11 minus 5. That'll give me 6 divided by 2. It'll map back on to 3. So we could see here that this equation does the exact opposite from this. Yeah? Is that these numbers that are in my domain map on to these numbers in the range, and if I was to take these same numbers and put them in this domain, it would give me the same numbers in the range on this side here. Right? So this is how we talk about the inverse of a function. Now let's just try one more example of the inverse of a function, right? Right. So let's just try this next example. We have f of x is equal to 5 minus 3x. And what I want is I want the f inverse of x. Yeah? So what I will do is I will recall that y is equal to the f of x. Therefore, y is equal to 5 minus 3x. And now I'll make x the subject of the formula. So 5 minus 3x is equal to y, right? Negative 3x is equal to y minus 5, because it's plus 5 on this side, yeah? Therefore, x is equal to y minus 5 divided by negative 3. And then the very last step is for me to replace my x with y and to replace my y with x. So therefore, y is equal to x minus 5 all over negative 3. Hence, the f inverse of x will be equal to x minus 5 divided by negative 3. So that is how you find the inverse of a function. It's actually pretty easy. Again, what I'll say is that I'm going to leave an assignment, a worksheet for you to do, and that assignment should be handed up on file paper in the next class. Or I might even ask you to upload your assignment online so that I could see it. It depends on when next we can have class. You know, this whole coronavirus thing, it's important to try to prevent the spread of it. So that's why we are doing these online classes instead. Yeah. So please, I hope that you understand. If you have any questions at all, just feel free to message me on WhatsApp or give me a call. You could video call me. I'll gladly explain anything over. And yeah, please stay safe during this entire corona thing. I hope that I'll see you in class soon. And look out for your next online class, which will be Tuesday at 6. Okay, so have a good day.